Welcome, everyone. Grab a seat. Today, we're diving into an explainer that might just save your grades and honestly, maybe even your sanity out there on the hospital floor. We are taking a masterclass journey straight into the fascinating world of memory and clinical problem solving. Look, this isn't just theory we're talking about. This is pure survival for us radiography students and practitioners. Let's get right into it.
Let's be real for a second. Have you ever sat down for a cat, flipped the paper over, and just felt your brain completely empty out? You're staring at an x-ray on the page, and suddenly every single bone in the hand has just completely vanished from your mind. We've all been there, right? It's that universal, terrifying feeling of memory failure right when you need it most.
But here is the secret. Retaining that massive, heavy anatomy textbook, it isn't magic. It is entirely about the process of encoding. You literally cannot just copy your buddy's notes, sleep with the textbook under your pillow, and hope osmosis is going to do the heavy lifting for you. Learning requires a very active, deliberate process. Okay, let's look at the syllabus for today. First, how memory actually works. Second, the 3 types of memory. Third, why do we forget? Fourth, clinical problem solving on the ward. And finally, some killer memory hacks for students. All right, starting off with section 1, how memory actually works.
So, how does all that dense, incredibly complicated medical information actually get into our brains in the first place? Well, it starts with the absolute most crucial step, encoding. Basically, this is changing information into a form your brain can actually understand and use. Think about learning patient positioning. You aren't just memorizing words on a page, you are actively translating physical movements and spatial awareness into a neurological language that your brain can actually hold on to. And once you've successfully encoded it, we move right along to storage, which is, exactly what it sounds like, keeping that information safe and sound for later. Think of your brain as this massive, intricate mental filing cabinet where you are systematically storing away thousands of pages of complex anatomy notes. Then comes the ultimate goal, the whole reason we do this, retrieval. This is recalling that stored information precisely when you need it. It's what happens when you are standing right there in front of a patient, the machine is prepped and ready, and bam, you instantly pull up the correct exposure factors from those mental files. All right, time for a quick pop quiz. Let's see who's really paying attention here. What process helps information actually enter memory? Is it A, retrieval, B, encoding, or C, sleeping in class? Now, I know some of you are very tempted to go with C, but as we just covered, the correct answer is absolutely B, encoding. Moving on to section 2, the 3 types of memory. Now that we know how the info gets in there, let me tell you, not all memories stick around for the same amount of time. Memory fundamentally moves across time. First up, we have sensory memory, which basically holds sensory inputs for just a few fleeting seconds. Think of briefly remembering the beep of a machine or a quick flash of an image on a screen. Next, we step up to short-term memory. This holds information you are actively using for about 20 to 30 seconds. It's exactly what you use when you briefly remember a patient's name as you walk them from the waiting room to the scanning table. And finally, the holy grail, long-term memory. This stores information from days to entire years. This is where you permanently store those complex radiography procedures. Quick rapid-fire question for you to keep the energy up. Which memory lasts the longest? Shout it out. Yep, you guessed it, long-term memory. That is the exact type of memory every single radiography student has to aim to build. Which brings us to section 3. Why do we forget? So, why do those carefully encoded long-term memories sometimes just vanish? It's super frustrating, right? Memory researcher Elizabeth Loftus proposed some brilliant theories to explain this, and we see them play out in medical college all the time. First, there's interference theory. This is when memories literally interfere with each other, kind of like mixing up 2 very similar radiography positioning techniques. Second is retrieval failure. The memory is definitely in there, but you just lack the cue to pull it out. It's that classic agonizing moment of blanking on an answer in the exam hall, only to remember at the absolute second you walk out the door. And third, decay theory. Basically, if you don't use it, the memory trace fades, like forgetting your ultrasound protocols after a really long holiday break. Now, beyond everyday natural forgetting, we absolutely must understand the organic causes of memory loss. These are often caused by physical trauma, like an injury or a stroke. We classify these amnesias pretty cleanly. First, we have anterograde amnesia. This is when a patient cannot form any new memories after the brain damage occurs. On the flip side is retrograde amnesia. Retro means backward, so this is the loss of memory of events that happened before the trauma. We also heavily encounter degenerative diseases in this field. It's a staggering statistic, but 1 in 10 people over 65 years of age are affected by Alzheimer's disease. It is the most common cause of dementia, usually beginning super gradually by causing a person to forget recent events, and unfortunately progressing to profound confusion and impaired judgment. Let's do another quick temperature check. If you learned something brand new, and it actually blocks you from remembering something old, is that decay, retrieval failure, or retroactive interference? Exactly. It's retroactive interference. This is the exact culprit when your shiny new clinical placements make you completely forget last term's anatomy knowledge. Let's transition over to Section 4, clinical problem solving. Because look, holding on to memories is only half the battle. The other half, actually using those memories on the fast-paced hospital floor to solve real, actual problems. Clinical problem solving is a highly systematic process. It kicks off with step 1, identifying the problem. And let me warn you right now, if you identify the wrong source of a problem, every single attempt to solve it will be utterly useless. Once identified, you must clearly define it. Then, form a strategy based on your clinical preferences. Next, organize your information. What do you actually know and what are you missing? Then, allocate your resources like time and equipment based on priority. And finally, you monitor your progress and evaluate your results.
But you gotta beware of the mental traps. These obstacles can cause some seriously inflexible thinking during your clinical rotations. For example, you might make false assumptions about your constraints. Or you might fall into functional fixedness. This is where you can only view a problem in the customary way, totally blinding yourself to alternative options. You might also get distracted by irrelevant, misleading information in a really complex case. Or you could get stuck in a mental set, just stubbornly trying to use a past solution for a completely brand new problem.
Finally, let's wrap up with Section 5, memory hacks for students. So how do you actually survive this rigorous, overwhelming radiography curriculum? You have to actively strategize. You absolutely need repetition and rehearsal to prevent that trace decay we talked about. You need to group information together and attach real, tangible meaning to the data so it actually makes sense in a clinical context. Write solid, highly organized notes. Use mnemonics for those tricky cranial nerves. And honestly, one of the best tricks out there, get into your study groups and pretend to teach the material like you're the lecturer. Create silly songs for the anatomy of the skull if you have to. Honestly, whatever creates a strong, unique memory trace that cuts through all that interference is a win. Which leaves me with one final question for you to chew on. How are you going to encode today's explainer so you can seamlessly recall it to solve your very next clinical problem? Don't just let this information fade into short-term memory. Take these psychological principles and actively apply them to your next shift, your next patient, and your next exam. Keep learning, keep encoding, and I will see you next time.